Welcome to the Truth Edu. Today we want to look at the topic SURDS. SURDS simply means the roots of any rational number. It can be root of 2, root of any rational number. That is what SURDS simply is, the roots of SURD. Basically, we have just 2 rules of SURD. The first rule is multiplication rule. That is when we have root A multiplied by root B. What are we going to do, or what do we have, is simply the root of A multiplied by B. Likewise, the second rule, which is the division rule, we have root A divided by root B is simply the root of A divided by B. Now, the other rules we can still talk about. Let's say we have A root B. So we have 2 numbers now. One is outside the root, the second one is inside the root. We can make it to be a single root. This A outside now, before you can put inside the root, you have to square it. This is now A square. So we have A root B, simply the A square B, the root of A square B. Now the fourth one we can talk about, just for us to have understanding of SURD, is when we have multiplication of same SURD. Root A times root A is simply A. Likewise, root B times root B give us B. Root 100 times root 100 give us 100. Just like, let's give just simple example for us to check. Root 2, let's say root 4 times root 4. This is 4, right? Because when we have root 4 times root 4, according to this first rule, to give us root 4 times 4, which is what? Root 16. And root 16 is 4. So that is what this fourth rule is telling us. And let's try to look at some things about SURD. SURD can be written in 2 forms. It can be written in basic form as well as single form. So any form written in this basic form can be converted to this single form. Likewise, from single form to basic form. So the basic form of SURD is just like we have 2 root 5. This basic form of SURD. Now we have a number outside the root and we have another one inside the root. So this one now we can write it in form of a single root, and we are going to apply the fourth rule we discussed that time. That's just 2 root 5 given to single form will give us this 2 will be 2 squared times 5, which is 4 times 5, which is root 20. So this is now single form of root. As you can see here, we don't have any number outside. Actually, we have a number outside, but the number is 1. You don't need to write it. Unlike this one that we have numbers other than 1. This is a basic form. So we can give different basic forms. Like we have 7 root 3. So if you want to compare it to single form, what is it going to be? It's going to be 49 times 3, and that will give us. So this is a single form and this is basic form. It's very easy. So from this basic form to single form, you can see the way we did it. Just put the square for the one outside and put inside the, multiply by the one inside the root. Now, how about from single form back to basic form? So here now, we have root 162. We want to combine to basic form. It's very easy. Now what I'm going to do is that you're trying to check what are the factors of this 162. And one of those factors must be perfect square. Perfect square are the number that have square roots without remainder. Like 1, square root of 1 is 1. Like 4, square root of 4 is 2. 9, square root of 9 is 3. And on like that. So now, what we're going to do is, let's try to divide this 162 by 2. Can 2 go in 162? Yes, it can go. So 2 going in 162 will give us what? 81. Give us 81. Is 81 a perfect square? Yes, that's what we need. In case 81 is not a perfect square, we try the next number, which is 3. We divide this 162 by 3. So anything that gives us is a perfect square. We continue doing like that till we get the perfect square. So here now we have 162 will give us 81 times 2. So from here now, we have 81 times root 2. That's the law of the rule of SURDS. When we have this 81 times 2 under the SURD, we can just break it to root 81 times root 2. So what's root 81? That is 9 times root 2. Simply written as 9 root 2. That is to convert from single form to basic form. The same method. We are going to use whatever you want to convert any SURD which is in single form to basic form. We have just one thing to know before we can try to add or subtract SURDs. The thing is that the SURDs to be added or subtracted must be similar SURD. It must be the SURD that have the same thing inside the root. For example, can we add this together? A root B and C root B. Yes, of course, they are similar SURD because we have B inside the root and B inside the root. But we can't add this A. This one can be done. What about A root B plus B root A? This one, we can't add it because the ones inside the root are different. This is not similar SURD. This is similar SURD. Same thing for subtraction. We can subtract the SURD in as far as they are similar SURD. We have the same inside the root. Now, what I'm going to do is this. If we have many numbers that many SURDs like this, I want to get confused. The best thing is for us to, in our mind, let's say this root 2 is A or root 2 is X. So let's use X for example now. So we have this root 2 to be X. So that means we have 7X plus 5X. We know what we are going to get. 7X plus 5X gives us 12X. Root 2 plus 5 root 2. So here, 7 root 2 plus 5 root 2, that's like 7X plus 5X. That is 12X. But I don't need to write X because my X is not actually X but root 2. So that gives me 12 root 2. Very simple. 7 root 2 plus 5 root 2 will give us 12 root 2. Just simply add the numbers before the root together and pick one of the roots. So same thing. Can we subtract these two SURDs? Yes, of course we can because they have the same number in the roots. So now if we want to find positive difference, this is bigger one, how to come first. But let's say we want to find the positive difference now. So how to for this one? So we have 43 root 7 minus 12 root 7. So in our mind, let's just put this root 7 to be A. So that means you have 43A minus 12A. What are we going to have for that? That will give us 31A. So this one is going to be 31 root 7. So just subtract 12 from 43. Then take one of the numbers in the roots, multiplication and division. Unlike the first subtopic, the last subtopic we checked, which is the addition and subtraction, which must have the same number in the root before we can add or subtract. This one doesn't matter whatever we have outside or inside the root. What I'm going to do is just to multiply the number outside the root together, then multiply the numbers inside the root together. So this one will give us, we have 3 root 5 times 7 root 4. So just multiply the 3 and 7 together. 3 times 7, 3 times 7. Then multiply the root 5 and root 4 together. Root 5 times root 4. So 3 times 7, this gives us 21. Then root 5 times 4, 20. 3 root 2 minus 1 multiplied by 4. So this one, like 4 bracket 3 root 2 minus 1. So 4 times 3 root 2. You know, this one doesn't have roots. We assume that this 4 is 4 root 1. That is what we assume. So now 4 times 3, 4 times 3, then this is root 1. 4 times root 2. So this was root 2. So times root 2, then 4 times minus 1, then minus 4 times 1. So this will give us 12 root 2 minus 4. As simple as this. That is multiplication of surd. Same thing for division of surd. Divide 4 root 21 by 2 root 7. So the solution of this one, 4 root 21 divided by 2 root 7. This will give us 4 root 21 divided by 2 root 7. Just divide 4 by 2, then divide root 21 by root 7. So 2 in 4 in brackets root 21 divided by root 7. So here we have 4 divided by 2 brackets root 21 divided by 7. So what do we have here? 4 divided by 2, this gives us 2. Then 21 divided by 7, that is root 3. Still on multiplication of surd. So let's say you want to multiply these two surds in brackets. Now you simply open the brackets. Solution. Now 3 root 2 times 7 root 3. That is 3 times 7. This gives us 21. Then root 2 times root 3. That is root 6. Then 3 root 2 times root 5. We have 1 here. So 3 times 1. That gives us 3. Then root 2 times root 5. That is root 10. Then minus 1 times 7 root 3. That gives us minus 7 root 3. Then minus 1 times root 5. That gives us minus root 5. We have the similar so that we can add together here, because now we have addition and subtraction. We have root 6 here, we have root 10 here, we have root 3 here, root 5. Very similar. No, just leave our answer. Now, conjugate of surds. The conjugate of surds means the number we are going to multiply by the surd to give us a rational number. For example, if I should have root 3, so if I multiply root 3 by root 3, I have 3. So that means root 3 is the conjugate of root 3. But in case we have a number like this, 2 root 5 minus 1, what is the number I'm going to multiply by this 2 root 5 minus 1 to give me a rational number? Is simply something like this, 2 root 5 plus 1. What have I done? Just change the sign from minus to plus. In case I have plus a, so the conjugate is going to be minus. So why? If I should multiply this and this together, I'm going to get a rational number. So let's check. So let's multiply 2 root 5 plus 1 by 2 root 5 minus 1. The same way we did the last one we did, we want to multiply the surds in bracket. 2 root 5 times 2 root 5, that is 2 times 2, that is 4. Then root 5 times root 5, don't forget the law, that is root 25 actually, and root 25 is 5 times 5. This is 2 root 5 times 2 root 5. Give us 4 times 5. 2 times 2, 4. Root 5 times root 5, root 25, which is 5. Then 2 root 5 times minus 1. That will give me minus 2 root 5. So you multiply this one by this, and this one by this is this. Then plus 1 times 2 is plus 1 times 2 root 5. That is plus 2 root 5. Then plus 1 times minus 1, that is minus 1. So now 4 times 5 is 20. Now minus 2 root 5 plus 2 root 5. That is like minus 2a plus 2a. That will give us 0 automatically. So we have plus 0, then minus 1. 20 plus 0 minus 1, that will give us 19. As you can see, we get rational number when we multiply 2 root 5 plus 1 by 2 root 5 minus 1. Therefore, 2 root 5 minus 1 is the conjugate of 2 root 5 plus 1. Likewise, 2 root 5 plus 1 is the conjugate of 2 root 5 minus 1. We have a surd fraction. I want to turn to rational number. What are we going to do? We simply multiply the surd by the denominator of that surd. You know, it is in fraction, and we have numerator and denominator. For example, now let's check this one. Let's say I want to rationalize. So what we have? 3 root 2 as a fraction. So what we need to do is just simply 3 root 2 times root 2 over root 2. Root 2 over root 2 is 1. We all know that. So what we are trying to do is just multiply this thing by 1. We want to get the rational number. So now we have 3 times root 2. This is 3 root 2 divided by root 2 times root 2, that is root 4. And root 4 is definitely 2. This is now rational number, because you don't have surd as the denominator. It is rational number now. Another example for us to have the better understanding. So what do we do? 7 root 2 divided by root 5 times root 5 divided by root 5. So 7 root 2 times 5 give us 7 root 10. Don't forget we have 1 times 7. 7 root 2 times root 5. That's root 10. Divided by root 5 times root 5, that's root 25. And root 25 is 5. So now we have our rational number. If I rationalize this, now let's check this example. So what are we going to do? We simply multiply the numerator and denominator by the conjugate of this denominator. So now solution: 5 root 2 minus 2 root 3 divided by 2 root 3 plus 2 root 5 times what is the conjugate of this denominator is simply this thing written back, but changing the sign from positive to negative, from plus to minus. So you have 2 root 3 minus 2 root 5 divided by 2 root 3 minus 2 root 5. So now we just expand. So 5 root 2 times 2 root 3, that is 5 times 2. That gives us 10. Then root 2 times root 3, that is root 6. Then 5 root 2 times 2 minus 2 root 5, that is minus 5 times 2, 10. Root 2 times root 5, that is root 10. Then minus 2 root 3 times 2 root 3, minus 2 times 2, that is minus 4. Then root 3 times root 3, that will give us root 9. Then minus 2 root 3 times minus 2 root 5, minus 2 times minus 2, that gives us plus 4. Then root 3 times root 5, that's root 15. All divided by 2 root 3 times 2 root 3, that's 2 times 2, 4. Then root 3 times root 3, that is root 9. Then 2 root 3 times minus 2 root 5. 2 times minus 2, that is minus 4. Then root 3 times root 15, root 5, sorry, that is root 15. Then plus 2 root 5 times 2 root 3, so that's plus. Then 2 times 2, that is 4. Then root 5 times root 3, that is root 15. Then plus 2 root 5 times minus 2 root 5. Plus times minus, that is minus 2 times 2, that is 4. Then root 5 times root 5, that gives us root 25. So let's continue. So we have 10 root 6a is 10 root 6 minus 10 root 10 minus 4 times what's root 9? Root 9 is 3. Then plus 4 root 15, all divided by 4 root 9 is 3, 3, minus 4 root 15 plus 4 root 15, that is minus 4a plus 4a, or minus 4x plus 4x. That one is 0. That one give us 0, is plus 0. Then minus 4 times what is root 25? That is 5. So now from here, numerator, you have 10 root 6 minus 10 root 10 minus 12 plus 4 root 15 all over 4 times 3, that is 12, minus 4 times 5, minus 20. So you have minus 12 here. So minus 12, then we have plus 10 root 6 minus 10 root 10 plus 4 root 15 all over 12 minus 20, that is minus 8. Minus 8. So you can just, if our answer is this, or divide everything through by certain. So now this is our answer, but you can just simplify it further. What is the factor of this minus 12? This 10 is minus 10a and 4a. You can see that 2 goes in everything. So we have, let's say, minus 2. Minus 2 times 1 will give us minus 12. That is 6. Plus minus 2 times 1 will give us 10. That is minus 5. We have minus 5 root 6. Here we have plus 5 root 10. So here we have minus 2 root 15 all over minus 2 times 4. So this cancel this now. This is our answer. 6 minus 5 root 6 plus 5 root 10 minus 2 root 15 all over 4. So in case you have any question, just write it down in the comment section below. Now we want to do radical equation. This example of radical equation. So solution: 3 root x plus 2 minus s equal to 4. So let's rearrange. You have 3 root x plus 2. This minus x, 4 plus x. That is, we add x to both sides. Now from here now, you can see this one has the root. This one doesn't have the root. You can just square both sides. Let's square both sides. Square both sides. We have 3 root x plus 2 equal to 4 plus x. So we root this, we square this rather. Square this also. So 3 square give us 9. Then root x plus 2 square, the root is going to cancel the square. That is times x plus 2 equal to 4 plus x square. That will give us 16 plus 8x plus x squared. When you expand this 4 plus x times 4 plus x, that is square, you're going to get this thing. Let's quickly do it here. 4 plus x, then 4 plus x. 4 times 4 is 16. 4 times x, 4x, x times 4 plus 4x, x times x squared. So we have 16 plus 4x plus 4x, 8x plus x squared. That's what we have here. Let's open this bracket. We have 9x plus 18 equal to 16 plus 8x plus x squared. So let's collect like 10. 9x should go there, then 18 should go there too. So we have 0 equal to this 16 is here. When 18 comes here, that is minus 18. Then we have plus 8x. When this 9x comes here, you have minus 9x. Then plus x squared. We have 0 equal to 16 minus 18. That will give us minus 2. Then this one, 8x minus 9x. That is minus x plus x squared. So now you arrange, we have 0 equal to x squared minus x minus 2, which can be written as x squared minus x minus 2 equals 0. This quadratic equation. So we solve it, we're going to get something like x squared minus x minus 2x minus 2 equals 0. So in case you don't know how to go about solving quadratic equation, you can just contact us and we guide you through on how to understand it very well, or just click the link that will be given in the comment section below, or click the link. We send the link to our tutorial on quadratic equation. Now here the factors, we have xa, then we have x minus 1, then we have minus 2a, that's x sorry. So here it's going to be plus. It's going to be plus here. Is this now? So x plus 1 equals to 0. Now, the reason why is that x times x is x squared. So x times 1, that is x. And minus 2 times x, minus 2x. Minus 2 times plus 1, that is minus 2. Now, take out the 1. So we have x minus 2 equal to 0, or x plus 1 equal to 0. Therefore, we have x is equal to 2, or x is equal to minus 1. That is our answer.